Hi guys, welcome to this live session by Great Learning. So guys, in this live session, we'll be covering the topic Docker. So it's basically an introduction to Docker. So I want a confirmation from you guys that you can see my screen and you can hear me. Now there's going to be a little bit of a lag. So while you guys are giving me that confirmation, let me show you something over here. All right, so guys, here at Great Learning, we started an initiative called Great Learning Academy. So go to your browser and type in Great Learning Academy, and the first link will take you to our website where we are providing a lot of courses that are completely free for everyone to basically learn from. They're completely free courses. I'm sorry, my net's a little slow. Yeah, okay. So here you guys can see a lot of different courses we have. We have Python for machine learning foundation, etc., etc. We have a lot of courses that we are giving out for free, and with free certification that will definitely help you in your career. So if you're interested, please visit greatlearning.in/academy. And also guys, make sure to subscribe to our channel and hit the bell icon so that you don't miss out on any of our future live sessions or any future videos that we release on the same topic or maybe any different topics. All right, so now that we're done with all of those, let me just see if you guys can probably see everything or not and hear me. All right, so I got a confirmation from you. Now we'll start with the live session. Also guys, so please go ahead and ask your questions during the session. I will try to answer them while I'm doing the session itself. I have the chat open next to me, and yeah, so let's move on. So this is the agenda for today's live session. These are the different topics we'll be covering. Issues faced before containerization. What is a container? Container versus VMs, that is virtual machines. Why do we need containers? What is Docker? What are Docker installation and setup? Docker environment, Docker common commands, and Docker architecture. So you guys can see two main keywords over here: containerization and Docker. So let's start off by discussing why is containerization such a big deal? Why do we use it in software development so much these days? So to understand that, we have to understand the issues we faced before containerization was a thing. Now, before it was a thing, we used to have standard delivery pipelines. So as you can see, this is a very simple yet standard delivery pipeline that was used for software development. Now there is a developer. Now this developer writes some code for a particular software. So when he writes that code, he sends it ahead for building. Now, when the code is building, the dependencies of this code, these dependencies can be your libraries or functions. They're basically taken together with the code and they're made into a single executable unit during the building process. That's what building is, where you build your code so that it becomes an executable. And once you get that executable, it is sent to the tester. But the tester tests for various things: integration testing, unit testing, acceptance testing, makes sure that the software has all of the requirements that were discussed in the requirements phase of this whole process. And if he thinks there are some issues with the code or the software, he will notify the developer about the same, and the developer will then go ahead and try to rectify those mistakes or those bugs that tester told him about. So once the developer rectifies them complete, does the writes the code again, he then sends the code again for building. So the whole cycle repeats. You can see the developer sends the code again, the code gets built with all of its dependencies, and the tester receives it again. Now the tester receives it again, and now he says that this code is totally fine and the software can go ahead to the end user, and it can be deployed basically. So the code then goes out for deployment, and in deployment it's basically given to the end user. So this is your standard delivery pipeline. Now this is very simplified. In real life scenarios, you'll have a lot of intricate details that are not given over here, but this is to give you guys an idea of how software is developed and what kind of issues we face over here. So this is the standard delivery pipeline. So what kind of issues can we face over here? So to see what kind of issues we can face, let's first discuss the environments of the developer and the tester. Now we have the developer. Let's assume that this is a backend developer, and this is his environment. So he has a CentOS operating system. It's a Linux distro, and he has the testing software PyTest 5.4.3 version. Then he is using PyCharm IDE for writing all of his code. and he's working on Django framework to write all of his backend code, and he has certain dependencies for that code. Now the developer himself is going to look at the requirements of the client, and then he's going to write the code, right? So he knows the context about it, and so does the tester, because tester would have also been in the requirements meeting. Now, the developer has written his code according to what he thinks is the best, possible scenario, where he uses PyTest's latest version, that is 5.4.3, because he thinks that, that's the best for testing purposes. His own certain, he will, do his own testing over there. So he thinks that this is the perfect environment for the code to be developed. Now let's look at the tester's environment. So we have a tester, and let's look at his environment. So he's also using the CentOS operating system. Now this may be the case that everyone's using the laptop that is provided by the company, and CentOS, comes in generally that, it comes as a standard OS that everyone's using. And he uses PyTest 5.3.0 because, he, even though, he was in the requirements meeting, the context of having the latest version of PyTest wasn't given to him, because that's something that the developer came by himself, while he was writing the code, and he wanted to test it for a certain test, and for that he needed 5.4.3. So he used that, but the tester still has 5.3.0. So you can see that there's a slight difference in the environment that it starts over here. And instead of using PyCharm, the tester uses Spider integrated development environment. Maybe it's his need, so that's why he uses Spider. But then he's working on the same backend code, that is, the Django code, and he's working on the same dependencies. So there are two slight differences. So what happens when we have these kind of differences in the environment? So let's see what they say. So the developer says, this code runs on fine on my computer. This is because the developer, made those small changes when his code wasn't running, and he made sure that the code was running on his system. Now he didn't deliver this context to the tester that I made these small changes, this, that, to make sure that the code was running. Maybe I, disabled the firewall, and I did these kind of things. Maybe he didn't tell that to the tester. So when he gave the code to the tester, the code did not run on his system. So the tester says this code does not run my system. So this is a big issue, because we have a standard delivery pipeline. We have to deliver our software on time, at a particular release schedule. And if the tester can't test his code, then he can't do his job, and we are getting delayed. Now he has to ask the developer what he did right to make sure that the code ran. So tester will take time to make those configurations on his system also. So this is a big problem. This is a big headache, especially if you look at the environment side by side, you can see that the mistakes can be clear. But then if the context isn't delivered, then they don't know about the configurations that they have to make. The developer has PyTest 5.4.3 and he has PyCharm IDE, whereas the tester has PyTest 5.3.0 and the Spider IDE. Now he can't run the same test scripts because the PyTest being used was different. So I hope you guys get an understanding why the issues are occurring. It's because of its compatibility issues. Maybe they use the same software, same environments, then they wouldn't have this kind of problem. So that's where our containers come. So let's now see what happens when we introduce containers. So you can see that it's the same delivery pipeline, but instead we are using containers. So what containers here do, they basically acts as containing devices. Like the name suggests of a container. Okay. So let's say, let's talk about shipping containers because they're kind of similar. So if you want to ship certain items from your country to another country, you do so, using, flights or maybe shipping containers. And inside of these containers, you'll add everything, or you'll store everything you want to ship. Similarly, containers act, like shipping containers itself, even in software development. So what the developer does is he takes all of his environment. He takes his CentOS, he takes his PyTest 5.4.3, he takes his, backend Django code, and he takes his dependencies, and he puts all of them into the shipping container or the container. And then he sends this container, instead of sending that code for building purposes, and then when the code gets built inside of the container itself, the tester receives it, and the tester does all of his tests inside this container. Now you can see that the container acts sort of a VM over here, because it does not, the software does not need to be executed outside of this container. It can make use of the resources inside of the container, like the operating system is inside of the container. So it doesn't have to depend on the host system, the tester's own laptop. It doesn't have to depend on the tester's laptop or system. It just has to depend on the container itself. So you can see that there is a consistency maintained where you're passing on the same environment also, and all the configurations have already been made in this environment, and the code runs in it. So all the tester has to do is just run all of his test scripts inside of this container. So this way, both the developer and tester go ahead and say that this code runs fine on my computer because there are no compatibility issues, and then it can go ahead for production. Even in production, we can make use of containers. So this is how containers solve a very big issue that we faced before containerization was a thing. It helped us to maintain consistent environments for software building, developing, execution, testing, etc. So this is why we use containers, right? So let's get into a little bit more detail about what is a container. All right, so let me just look at some questions you guys might be asking. Where we use Docker. Docker is used in software development. Like I'll get to it. I'll eventually get to it. All right. So somebody's asking for a Hindi video for Docker. Yeah, Prakash, we have a Hindi video also on Introduction to Docker. You can go to our channel and check out Introduction to Docker in Hindi. So if you're interested towards that, you can obviously go and watch that. All right, so now let me continue. What is a container? So let's discuss this. Containers are software that wrap up all the parts of a code and all of its dependencies into a single deployable unit that can be used on different systems and servers. So just like I discussed before, you take the code, you take the libraries, and you take the environment. This environment can be configuration details on a certain operating system, and all of it's taken together and put inside of a container. So this container itself acts like a system in which you can execute your code, develop your code, and build your code and test your code. So that's what a container is. Alright, so to get a better understanding of what containers are, we can compare containers to virtual machines or VMs to get a better idea. So if you guys don't know what a VM is like a basically, we are virtually simulating an operating system inside another operating system. So let's say you're working with Windows system, you work all your life on Windows, but you want to test out Ubuntu, but you don't want to dual boot your laptop. You just want to test it out. So you download a VM and you run an Ubuntu operating system inside of this virtual machine in your system. So that's what a virtual machine is. It's a virtual machine. So containers are very similar to the idea of virtual machines. So let's compare both of these to understand the container to understand what a container is much better. So to compare containers and VMs, we're going to set some criteria like operating systems, architecture, isolation, efficiency, portability, scalability, and deployment. All right, so let's start. All right, so wait one second. I have a few more questions over here. Containers are virtual environments, so this will reduce the computation speed, correct? As if in normal execution time in 5 seconds, then it will be more in a container, correct? So the thing with containers are they are absolute bare minimum parts of operating system. That means that you don't have anything extra, any miscellaneous things. So let me just finish this up, then I'll answer this question because you'll understand that much better. So let's compare how the containers have operating system versus how the virtual machines work. So containers, right? They contain only the bare minimum parts of an operating system required to run the software. So let's say you are running Ubuntu inside of your container. So you won't be running the whole Ubuntu thing. You won't be making use of the graphical user interface. You might not make use of MP3 player. So all of those extra things that you normally use in a general operating system, those won't be there. It won't be general purpose. It will just be for for processing, for job scheduling, for processor managing. It's only going to be for that. You can run software on it, but it won't have any extra software with it. So it's very, very bare minimum, and that way the amount of resources required to run anything on this are way lesser, because the operating system won't require as many resources, and it's very easy to update them, and it's very simple to do so also in containers. Versus with virtual machines, right? Virtual machines are like completely, they're complete operating systems. So they have all the parts a normal operating system would have. So let's take the example of Windows again. Now Windows has a lot of different things. It has its own kernel, it has its apps and services that work on it. So all of it together will be inside of a VM. not just the small things. I mean, it's going to have all the small things also, but not just that. It's going to have the complete thing. Whereas with containers, you only have the bare minimum parts that are required for running any particular software. So let's look at the architecture. It will give you guys a better idea again. So the architecture of container versus VM. So in container, you can see that there is a host operating system and it sits on the host hardware. Inside of the host operating system, you can see that it has its own kernel, it has its own apps and services, and container, it acts like a program over here. It shares the kernel with the host operating system. So it gets the resources from the host operating system's kernel itself. Even though it has its own apps and services, it makes use of the resources that is given by the host operating system. Whereas with virtual machines, you can see that the whole architecture is completely different. The host operating system is completely isolated from the virtual machines, operating system. They both share the same hardware, but then the virtual machine acts like its own operating system inside the host machine. It has its own kernel, it has its apps and services. Now the resources that are needed to run the virtual machines are gathered through something called a hypervisor. We don't need to go into more detail about it. Just understand that it gets all of its resources using the hypervisor. So you can see with the difference between container and VM's architecture. Whereas container here, even though it does act like a VM, it's not completely a VM because it does not have its own operating system, like own space for an operating system. It just shares the kernel from the host operating system itself. Whereas with virtual machine, it's its own separate thing. So this is the difference between the architecture of container and VM. Isolation. So let's see how well isolated both of these are. So with containers, right, the isolation provided isn't as complete as of a virtual machine, but it is adequate enough. So there are, user-defined methods where we've included isolation, but it's not complete isolation like we saw with virtual machines. So virtual machines provide complete isolation from the concerning host system, and it is also way more secure in this matter of fact because it's completely separate from the host operating system. So if something happens to the host operating system, like if there's a malware or something, it will barely affect the virtual machine. So even though VMs provide more isolation, the containers provide enough isolation, and we can introduce more methods for this, increasing any layer of isolation we want, like adding networking. So let's see the efficiency of container versus VM. So this is somewhat related to the doubt asked before. So in containers, right, containers are way more efficient as they only utilize the most necessary parts of an operating system. Since they only utilize the most necessary parts, they act like any other software on the host system. So they don't, utilize as many resources as a normal operating system would. Now, an operating system you might not think is heavy, but it is actually very heavy. So it's normally like it's like the size of 1 GB or something. But in containers, normally the size of the operating system would be like 100 MB or 200 MB. So it would be like that. Whereas with VMs, again, it will be like 1 GB or 2 GB. So you can see the size difference over here. It's pretty vast. With VMs, they are less efficient as they have to manage the full-blown guest operating system. They have to manage the graphical user interface also, any third-party apps that might be downloaded, and all of that has to be managed. So VM, they are not as efficient as containers because when you're running a software, you don't necessarily need all of those extra things, right? You may only need the bare minimum parts. So that way, containers are way more efficient as they require less amount of resources. All right, so let's see the portability of container versus VM. So containers are self-contained environments that can be easily used on different operating systems, whereas VMs aren't that easily ported with the same settings from one operating system to another. Now, this again relates back to how containers are very lightweight. They are very lightweight because they only have the bare minimum things of operating system, so it becomes very easy to transport them because they have such smaller sizes. And also containers themselves are kind of platform independent. You can move a container from here and there because inside you're going to have the same environment. So containers are way more portable than VMs. All right, let's talk about scalability. Now, scalability is an important factor in software development because if you're a company and you want to see some kind of growth in your company, you'll definitely need to increase the amount of services and servers you're using. So for that purpose, you have scalability. You need to scale your operations to match your growth. So that way, what happens when you want to introduce more servers, more containers, more virtual machines? Then you have to use either containers or VMs. So with containers are very easy to scale. They can be easily added and removed based on requirements due to their light weight. Whereas with virtual machines, they aren't very easily scalable as they are heavy in nature. So with containers, you can easily add and remove any container because they're so lightweight. Whereas with virtual machines, they aren't. It's not that easy. You can do it, but it's still it's a hectic process. So again, container gets the win over here because it has better scalability. All right, so deployment. Now, deployment is where you deploy your software. You make use of all the different, containers that acts as servers and virtual machines to deploy your software. So in that case, also, containers get a bigger win because they're so easy to deploy. They can be very easily deployed using either Docker CLI or making use of orchestration service like Kubernetes, or you're making use of cloud services provided by AWS, Azure, or Google. And virtual machines similarly can be deployed using PowerShell or by using virtual machine managers. And they can also be deployed using cloud services such as AWS or Azure, right? So, the guys, I hope you guys understood the differences between containers and VMs. Now, understand that in real life software deployment, VMs also have some advantages. Now, I've bashed VM a lot over here comparing to containers, but VMs also have a lot of advantages. So normally you would have a hybrid system where you're using, both containers and virtual machines in software deployment. All right, so when you talk about containers, you can have multiple isolated containers that can be launched together to form something called microservices. So you have microservices architecture where you have multiple containers forming one single application. Now they're normally managed by services such as Docker Swarm or Kubernetes. You don't have to worry about them right now. We'll talk about them in future sessions. All right, so why do we need containers? Let's just summarize it again. One of the reasons is to have consistent development environments across software development process. And another reasons that I haven't told you guys about is microservices. So when you are actually deploying an application, right, any software, these days, you don't do it, or even, you don't do it normally by deploying a software in a single file. Now, as college students or as school students, we used to do that because we didn't have vast projects. We had like smaller projects, or even if we had vast projects, we did it in single files. We deployed those single files. So that's not how it works. That's a monolithic architecture, and that's very antiquated, and it's not suitable to today's market. And that's why we use microservices architecture. So the microservices architecture is pretty self-explanatory with the name itself. They're microservices. So you have multiple services that form a feature. So let's say we have 5 features that together form an application. Let's say you have a food delivery app, and inside that food delivery app, you have many features. You have the payment feature, you have the tracking feature, you have the shopping feature, you have another shopping feature, and you have a lot of different features. You have 5 features that together form the software as a whole. So to launch these features together, we make use of microservices architecture. That is, just having these features separate in smaller parts and in chunks, and being, launched in containers. So containers help us to launch these features as single microservices that are connected, interconnected, and interdependent. So these are the 2 reasons why we need containers. All right, so I'll look at a few more questions that you guys have asked, then we'll continue. So what is an operating system? Well, operating system, I mean, to go into more detail, it would take a lot of time. Operating systems are like, Windows or Ubuntu, right? So those are your operating systems. So they help you to basically perform different functions like browse internet. Your phone's Android system is an operating system. By programs, we mean specific libraries or environments. So if a container can run any software, so can it show GUI of that software also? Also can be directly run an exe in a container. All right, so so you can have the GUI of that software also. That's obviously going to be there. That is a part of that software. So when I say you deploy a software inside of a container, you are deploying everything about that software in that container. The container acts sort of an infrastructure. Your software is going to remain the same. It just acts sort of an infrastructure. Yes, you definitely can run .exes in a container. Do we need multiple images to deploy multiple services? Well, it depends on your requirements. So if you want to launch different services that are unique in nature, then you will need unique images for that purpose, because you are deploying the services and they have certain configurations, so you'll have to have unique images for that. But if you want to launch, well, I guess by definition services means they're going to be separate from each other. So yeah, you will need multiple images to deploy multiple images. So services. So what are the minimum configurations needed to install Docker? Okay, Karna, we will cover that. I have planned to cover that, so we'll talk about it. A container is like a VM which has separate OS, app, and hardware, right? No, it does not have separate hardware. You can have separate operating system and apps in it. So just refer to, okay, we will talk about what is an image. So all right, so the questions will be covered when I continue the session. All right, so what is Docker? So Docker is basically the tool that helps us to create those containers. So we know what containers are, and how do we create them? We make use of Docker. So Docker is an open source tool that a company called Docker had created back in 2013. So it allows us to basically take an application, put it into a set of containers, and then deploy it. So if you wanted to create containers, you would use the tool called Docker. Now there are other tools also out there in the market. You have LXC containers and RKT containers. You can make use of them also, but Docker is by far one of the most popular open source tools for creating containers. Now, the isolation provided by containers also gives a layer of security to this container. So when you're creating containers using Docker, right, you have a layer of security over those containers. Right. So why Docker? So they have a list of reasons that Docker themselves, it's a company, so they post it on their website. So they say that Docker is simple, it's fast, easy, it has easy collaboration, it's built for developers by developers, and it has a very large Docker community. So all of these things are true. Docker is very simple to use. It is, it's very fast in deployment, in deploying any application. Easy collaboration, definitely true, because you have DockerHub and different Docker registries. You just have to share your images for certain containers, and you can deploy your containers on local systems. Then built for developers by developers, yes, they are developers and they have developed it in keeping in mind that developers need to use these things, so they've made it perfectly for them. And Docker community, yeah, Docker community is one of the largest container Docker communities, where a lot of people, different people contributes. And Docker company also takes in these contributions and adds them to the software itself. So there are two versions to this Docker tool. You have Docker Community Edition and you have Docker Enterprise Edition. So Enterprise Edition has a few more things that aren't really necessary, but if you want to go for that. All right, so let's get to Docker installation and setup. So you can install Docker basically on any Linux operating system, Windows, or even Mac, right? So I'll tell you guys how to do it on Windows, and we will actually be working with Linux. All right, so let me go to the browser. Okay. So if you want to download Docker for, just type in download Docker for Windows, the first link itself. So you will have the requirements for having Docker. So just scroll down and these are the system requirements. You need to have Windows 10, 64-bit, Pro version, Enterprise version, or Education version. So it has to be this build or later. And then you need to have a Hyper-V and container window features enabled. You need to have a 64-bit processor with a second level address translation, 4 GB systems of RAM, and BIOS level hardware virtualization support must be enabled in BIOS. So you need all of these requirements to run the latest version of Docker that they are providing. But if you don't have Windows 10 or you don't have these versions of Windows 10, there is a way to work with Docker on Windows still. Just scroll down over here on the left hand side and look for suspended products and tools. So in suspended product and tools, you will find Docker Toolbox. Just click on Toolbox overview. So Docker Toolbox is something that basically was used earlier to work with Docker on Windows, right? Now installation for Docker on Linux is much easier. So let me just go ahead and launch an instance using AWS. I will launch an Ubuntu instance, so we can work with Docker. And storage tags, configure security group. So I'm gonna use a existing one. So basically, I'm making it all traffic and anywhere as the source because I don't want any networking issues. Now that isn't definitely not secure, but in production and in actual development, it will be, you can add more methods to secure it, like session keys and launching instances. All right, so I'll look at the questions while this is loading. All right, so in your example of food delivery application, assume that it has a web component and a services level. So we need to have two Docker containers, or can we have both components in a single container? Now, ideally, you can you'll have all of them separately, both the web component and the services level. So you'll have them in separate containers. But if you wanted them to have in a single container, you could do that also. Depends on your requirements and how many resources you have. So it's like measuring between how many resources you have and how many services you have. But I suppose as a company you would have a lot of enough, at least enough resources to launch all of these different services in different containers. So yeah, you would basically be launching all of these different services in different containers, both the web level and the services level. You'll have database also, so that will also be there, so you can even launch that. But a lot of people don't then generally launch databases on containers. What they do is they use services that are provided on AWS itself, the database management systems. So they connect that rather than creating their own database on a Docker container. So let me just copy this IP address. All right, so we have this thing, Ubuntu instance open. So there are two ways to basically install Docker. So you can go ahead and use Ubuntu's own repositories. So for that, all you have to do is update the instance first, sudo apt update. And once you're done doing that, you can go ahead and make use of this command, that is sudo apt install docker.io. So this is basically installing Docker from Docker Ubuntu's own repositories. You may not get the latest version of Docker with this, but it's very easy. So for practice purposes, or if you just want to have a quick testing of it, then you can go ahead and use this command, that is sudo apt install docker.io. Can we monitor the resources used by Docker and containers separately? Well, you can monitor them separately, or you can make use of tools like Grafana and Prometheus to monitor your containers. If you want, you can even launch your monitoring tools inside of containers if you want. So yeah, definitely you can monitor them. So let me just clear this. So we have Docker installed. To see if Docker is installed or not, you can type in docker hyphen hyphen version. So this will give you the version of Docker that you are using, right? So I'll show you guys the second way also. Let me just remove Docker and we'll install Docker again using the other method. So the other method is basically is installing Docker directly from Docker's own repositories. So sudo apt remove docker.io. All right, so while it's removing, let me show you the list of commands that we'll need. So this is for setting up a Docker repository and installing Docker CE, that is community edition. So this is the direct method. So we've already updated it. So let me go ahead and copy this command. So this is for basically installing a set of packages like app like app transport, HTTPS, CA certificates, etc. Then we will go ahead and get the key for the repository. So this is the command for that, curl -fssl Now, if you want this thing, these commands, you can get them directly from Docker's documentation. They have provided these set of commands. Now we'll get the stable repository. We'll add the stable repository so we can download Docker directly from here. All right. So now we will go ahead and update again, and we will install Docker. All right. Till this is happening, if you guys want to ask any questions, you can go ahead and ask them. Let me just check if you guys have already asked any questions here. All right. So it's installed. So let me just type in Docker version to see if it's installed or not, and the version of Docker. Right. So let me just spell that. I missed a K. All right. So this is the version, and we have installed Docker successfully. All right. So guys, this is the installation process of Docker in Linux. So let's move on. So now let's understand the Docker environment. So you guys will know how Docker works and what are the different parts to Docker, right? Okay, so these are the different components of a Docker environment. You have Docker engine, Docker objects, Docker registry, Docker compose, and Docker swarm. So those are the basic components of a Docker environment or Docker ecosystem. So let's look at Docker engine first. So Docker engine is, as the name suggests, is the technology that allows us for the creation and management of all Docker processes. It has three major parts to it. We have Docker CLI, we have Docker API, and we have Docker daemon. So Docker CLI is basically all of the Docker command line interface. It's basically us using all the Docker commands to request for certain processes to happen. If you like, we did Docker version over here, right? So Docker version was, us asking Docker daemon to tell us what's the version of Docker. So that's what happened. So you basically type in all of your requests using Docker CLI, and Docker API is the method of communication between the CLI and the Docker daemon. So whatever request we give in, it will be taken up by the API and communicated to the daemon. So the daemon is the one that does all of the core things. It processes everything. It manages all the processes. So if we create an image, if we create a container, if we create a network, all of it's done by a Docker daemon. So let's say a user types in for a particular request. That request will be communicated using the Docker API to the daemon, and the daemon will go ahead and create the either the container, the network, or the volume. Okay. So now let's discuss the different Docker objects there are. So we have a lot of objects over here. We have Docker images, we have Docker containers, Docker volumes, Docker networks, and Docker Swarm nodes and services. So for now, we'll ignore Swarm nodes and services because that's a little bit more advanced topic. We'll just go through the rest of them. So Docker images. So Docker images are set of instructions that are used to create containers and execute code inside of it. So you guys know what a container is, right? How do we create a container? To create a container, we need a sort of a blueprint. So let's say you want to create a house. How do you create a house? To create a house, you need a blueprint for that house, a plan of that house, a set of a detailed instructions on how to create that house. So similarly, a Docker image is basically a blueprint for a container. So if a user wants to launch a container, he will take the Docker image, or he will create his own Docker image, and he will run that to basically run a container or create a container. So if suppose say you wanted to launch a Linux or Ubuntu container, then you will create an image that specifies Ubuntu as the base image to be used. And when you run this image, you will get a Ubuntu container with Ubuntu inside of it. So these are your Docker images. So let's understand what all of these by using the Docker common commands. So there is a command called docker pull. So what this basically does is that it pulls a image from Docker Hub. So Docker Hub is a it's a place where you store different images. So just go to hub.docker.com and you will find a lot of different images. Let me just show you. So we're going to hub.docker.com, and over here basically you can type anything. If you want Ubuntu, you can type in Ubuntu and you'll find an image for Ubuntu over here. So if you wanted to pull any image from this central hub place, then all you have to do is type in docker pull and the name of the image, so it will start pulling it. So let's get root access and let's do the same thing again. So you can see it's pulling from library/Ubuntu, and it's pulled a Docker image, that is the Ubuntu image. To see where your images are, to see what all images you have on your system, you type in Docker images or Docker image ls. So it will list all the different images you have on your system. So right now we have Ubuntu image. The tag it is using is latest. You can have different versions of Ubuntu also if you want. Then the image, that is image ID, is this. It was created 5 days ago. That means somebody updated this image on Docker 5 days ago. And you can see the size. The size is 73.9 MB. So you can see how small the image is. So when you create the container, right, it's going to be of this size. So you can see the whole advantage of having Docker containers, right? Okay, so now let me show you guys how to run a image. So you type in docker run, that is the command, then write -it -d and the name of the image you want to use. So this is the syntax: docker run -it, this makes the container interactive, and -d, so this is a detached flag, it makes the container run in the foreground. So, and this is the name of the image. Now we can do one more thing. We can add a name for this container. To add a name for this container, you have to use the flag name --name, and then you can type in my container and press enter. So you'll get a long number. This indicates that your container has been created. So to check if your container has been created or not, just type in docker ps. So it stands for process status. So if I press enter, I can see container ID, image, command, created, status. So you can see this is the container ID. This is the image that it used to create the container. This is the command, and it was created 13 seconds ago. And it's up. That means it's working. And this is the name of the container. So let me just reduce the size so you guys can see it without any formatting issues. Docker ps. Yeah. So hope you guys can see better. So this is a container. So we have launched a container that has Ubuntu inside of it. Now I want to show you guys how you can go inside of this container. To go inside of container, you make use of a command called docker exec. So here also we'll use the interactive flag, and we're going to go ahead and copy the container ID and paste it, and we're going to write bash. So what this command does is it basically allows us to go inside of the container by making it interactive and using the bash terminal. So if I press enter, you can see that I'm in the bash terminal, and the IP has changed. It has changed from the instance that I've launched to the containers ID. So this means I'm inside the container. So if I do an ls over here, you can see that I have all the necessary parts for Ubuntu over here, right? So if I wanted to perform any commands of Ubuntu like apt update, you can see that it will start updating from the Ubuntu's repositories, right? And if I wanted to install anything, apt install Apache 2, I can go ahead and do this, but it will be a long process. Let me not show you. So to exit a container, just type in exit and you will come back to your instance, right? So let me just show you again docker ps to see all of your commands. Now if you want to stop a container, you can go ahead and use the command docker ps, sorry, not docker ps, docker stop and the ID of the container. So this is the ID of the container. Just paste it, press enter, And if I do a Docker PS again, I can see that there are no containers anymore over here, because Docker PS only shows all the running containers. It does not show any stopped containers or removed containers. If I want to see any of the stopped containers, I have to type in Docker PS -A. So -A is like alt flag. So it will show us all the images, whether they're running or exited. So you can see it's exited because we use the Docker stop command. Now if you wanted to bring back up, or if you wanted to bring it back up, you can use the command Docker start and the ID of the container again. This will start a container again, and if we do a Docker PS, we can see our container is back up. So up 3 seconds, right? All right. So two more commands. So I'll show you guys Docker kill. So this is similar to stop, but it does so forcefully. So sometimes stop won't work because some kind of process is running or Docker container is involved somewhere. So if you want to forcefully stop a container, then you use Docker kill command. So if I do a -A, you can see that it's exited. Okay, so let's just start. Okay, so we have stopped the container. What happens if you want to remove the container completely from records? So I'm going to go ahead and type in Docker rm and -f. I don't need -f, but you can use -f when you want to forcefully remove a container. So this way, if I do a Docker PS again, I won't see any containers at all because I've removed it completely. Okay. All right, so we work with Docker. Now I want to show you guys how to remove images also. So you have Docker images. So if you want to remove any Docker images, just type in Docker RMI and the name, the ID of the image. It will remove all the images that you have specified. Okay. So these are a few common commands that you guys need to start learning Docker with. So I hope you guys understood them. Now let's come back and understand the different environment objects. So we have volumes. Now Docker volumes are basically persistent storage locations for containers. They can be easily and safely attached and removed from different containers. So imagine volumes like hard drives. So you have containers, right? Containers don't permanently store data. To store data permanently, you make use of volumes. So just like we transfer data from one laptop to another using hard drives, we use volumes to basically transfer any data if you want from one container to another. It's not necessarily transferring data, it's just acting like a storage device. So a volume can act as a storage device for one container, or it can act a storage device for different containers. You can safely and easily remove a volume from one container and attach it to another one, and then remove it from another one, and then you attach it to another. So these are Docker volumes. So Docker volumes have Docker volume drivers. So they basically enhance the abilities of a volume. So drivers allow you to perform unique abilities such as creating persistent storage on other hosts. So these volumes, they are storage locations. So they get mapped to certain locations on your host system. If you want, you can map them to hosts also, or to cloud. Or if you want to encrypt your volume, then you can go ahead and do that also. They basically enhance the abilities of a volume. Docker volume drivers. All right, so now discuss network. Networks are important because a Docker network is basically a connection between one or more containers. One of the more powerful things about Docker containers is that they can easily be connected to one another, or even other software. So this makes it basically easy to isolate and manage the container. So if you have like 3 containers, right, and if you wanted to if you wanted to make sure that these containers are talking to each other, then we will go ahead and use a Docker network to connect all of these 3 containers. Now this is one set of Docker containers. This one set including 3 containers. Now we can have another set which has another 3 containers, and they also can be connected to each other using a certain Docker network. Now, if you want to connect all of these together, then you can also do that. You can make use of another Docker network that can connect all these different sets of Docker containers. So there is a layer of isolation that you can create. So if suppose I created a container outside the layer of this network, then it will not be able to talk to any of these containers. So it creates a layer of abstraction where it only creates a need to know basis connection between these containers based on your requirements. So that's a Docker network. Alright, so let's talk about Docker Registry. I've already told you guys a little bit about Docker Registry. So DockerHub is a Docker registry. It stores, it's an official Docker registry. So let's talk about Docker Registry. You can think of a registry as storage location for Docker images. So if you want to store your Docker images in a certain location, you can do that, and that location will be called Docker Registry. These images can be versioned also. So you can have different versions of a certain image. You can have version 1, version 2, version 3. And once they're stored in Docker registry, they'll be there for posterity until you delete them, or until the internet goes down, and anyone can take them. One user can take them, another second user can take them. So this allows for easy different teams and different team members. So if you want to share your images, then you would go ahead and use a Docker registry. So you have many options for Docker registry. You can go with DockerHub as your main Docker registry, as there's already a Docker command to pull and push the images. If you don't want to use DockerHub, there are many alternatives. So DockerHub is basically the official Docker registry. If you want to set up your own Docker registry, you can do that. The thing is that many people prefer DockerHub because there are already proprietary commands for it. Like in Docker CLI itself, I can do Docker pull, right? So that will easily pull any images for me because it already knows to pull from the Docker Hub. If I wanted to configure it to pull from other places also, I can do that. I can use AWS's ECR, that is Elastic Container Registry, or JFrog Artifactory, which can also be used to store images. And you can use Azure Container Repository also, or registry. All right, so that's it for Docker registry. Now let's go through Docker Compose and Docker Swarm. So Docker Compose, for now, just understand that Docker Compose is just a service within Docker that lets us launch multiple containers at the same time. So if you guys remember, we did Docker run, right? So when we did Docker run -t -d and the name of the image. So this was only running one container. So what happens when you want to launch multiple containers at the same time? You make use of a Docker Compose service. So basically, where you write a Docker compose.yaml file, inside of that YAML file, you write all the configurations for each service or container, and then you build that .yaml file. And once you build it, you will have all of your containers. Then we have Docker Swarm. So this is an orchestration tool. When you deploy in actual production environments, you make use of Docker Swarm or similar orchestration services like Kubernetes or ECS or EKS, where you're managing multiple containers at the same time. So for now, just understand Docker Swarm is a service within Docker that allows us to manage multiple containers. So we've launched multiple containers. How do we manage those multiple containers? To manage those multiple containers, we make use of Docker swarms. So basically, we group all of the containers in certain swarms, in clusters. So in each cluster, you'll have a manager node and you'll have worker nodes. And you'll manage them using Docker swarm commands. All right, so we've understood a lot about Docker. We've understood the whole environment. Now, before I move on to the final architecture, the flow of a lot of things, I want to check a little questions again. Okay, so Farhan has asked a question: is Kubernetes and Jenkins similar to Docker? So they're not the same, but they help us to, they help us to basically, in the end, help software development. So Jenkins is an integration tool. Jenkins integrates all the different parts of software development, where you're developing, where you're testing, where you're monitoring. All of it is integrated using Jenkins. Now Kubernetes, right? It's an orchestration tool solely, whereas you're not creating containers using Kubernetes, but you are managing them. So I talked about Docker Swarm, right? So Kubernetes is almost exactly the same, but it's much better and it's much more popular. So people generally, what they do is they create containers using Docker, but then they manage it using Kubernetes. But it's not a must. It's based on your requirements. So, do we need any tools to monitor Dockers? Yeah, you'll definitely need to monitor your Docker containers. So again, you can use tools like Grafana and Prometheus if you want to monitor your Docker containers. All right, so they're not included, but Rakesh, there's a very simple Docker command. Just if you want to install Docker on Ubuntu, just type in sudo apt update to update your Ubuntu instance, and then sudo apt install docker.io. And those commands, those specific commands, you can go ahead and check them out on on Docker documentation. Now the documentation will give you all of those commands. If you don't have those commands, just pause this after this video gets uploaded and you can copy them. Difference between Docker and Kubernetes. So I'll make a video exactly detailing all the differences between Docker and Kubernetes. ECR alternative data hub, Docker Swarm alternative for ECS. Yeah, you can use it. You can use ECR and ECS together. You can use ECR and ECS together if you want, based on your requirements really. If you want to learn more about AWS and how to use AWS for software deployment, you can go ahead and use it. It's definitely on you. All right, so now let's discuss Docker architecture. I'll give you guys 3-4 minutes before the end of the session to ask all the questions again. So Docker architecture. So Docker architecture, basically we have Docker CLI, that is a command line interface, Docker host, and Docker registry. All right. So inside of this, right? So basically we use the Docker CLI to give Docker host any commands we want. So let's say we want to give these commands: Docker build, Docker pull, Docker run. So what happens with each of these commands? So with Docker build, you're basically building an image. Create your own image and not pull from the registry. You make use of Docker build command. So for that, you write a Docker file in which you give all the instructions to build an image. So we know we want to create a container. To run a container, we make use of images. How do we build images? To build images, you use Docker file. Now, Docker file, you use Docker build command. So Docker build will basically tell the daemon, I want this particular image, and daemon will build that image based on the instructions you've given. Then there's Docker pull command. It basically tells daemon, I want an image from the Docker registry. Then you can go ahead and pull it from Docker registry. So let's say you're doing pulling Apache web server, then that Apache web server will be pulled to your local host. And then you have Docker run command, which will basically tell daemon to run an image. So it will run the image to create a container. So this is basically kind of like the whole life cycle and how commands would work when you're working with Docker. All right, guys. So go ahead and ask me any questions if you have. I'll check them in the chat and answer them. Is Docker Swarm better than Kubernetes? Um, it's generally Kubernetes that is better than Docker Swarm, but there are small differences. Docker Swarm is generally not used that much on a large scale level. If you wanted to use this on a small scale level, you can use Docker Swarm. If you're practicing on learning how to orchestrate multiple services together, then you make use of, Docker Swarm. But if you want to do it like actual production, in production, then a lot of people prefer Kubernetes because Kubernetes is more robust and it provides better security features also. Kubernetes. That's why people use Kubernetes. All right, guys. So I assume all of your questions have been answered. So I'm going to go ahead and end the session. Thank you so much for watching. I'll see you guys in the next live session. Oh, wait, we have one more question. How to expose port 4333 on 80 on a container? All right. So if you want to expose a port, you can mention that in your Docker file, or you can go ahead and mention it in the command that you're writing. So in the Docker run command, just type in 8080. So this is just an example for you. So this will basically map the port, expose the port of the container 80 to the port of the host, to the default. So you can go ahead and change the value and make it 443 to expose it at the port 443 to the port of the host. If you want to port, the host port to be 80, you can leave it. So it will be the default port and you can change this to 443. All right. All right. Now I'm going to go ahead and end the session. Thank you so much for watching.